Let's do this problem from your lab assignment, section 11.11. It says to use the alternating series estimation theorem to estimate the range of values of x for which the given approximation is accurate within the stated error, and then check your answers graphically. We have a sine function which is approximately equal to x minus x cubed over 3 factorial, or 6. And they want the error to be less than 0.00000001. Okay, so we know that the sine function is equal to this infinite series. Well, they gave us this already, so it's the first term is x, and then we have minus x cubed over 3 factorial, and then 5 x to the 5th divided by 5 factorial. 5 factorial is 6 times 4, which is 24, times 5, which is 120. So we have 5 factorial there, 120. By the alternating series estimation theorem, what they're saying here is that the sine function here is less than the next term. So the error in approximation for the sine function is going to be less than whatever the next term is going to be for values that are sufficiently close to 0. So our next value, I think, is going to be, well, it's this term, x to the 5th divided by 5 factorial, or 120. Okay, so that worked out. Now we want the error to be less than this number here, so we have to solve for this thing. It looks like they multiplied 0.0 whatever this is by 120, or 5 factorial. So let's take out our calculator for that. We got how many zeros here? 1, 2, 3, 4, 5, 6, and a 1. 6 zeros and a 1. 1, 2, 3, 4, 5, 6, and a 1. And then we're going to multiply this by 5 factorial, which is 120. And we got 1, 2, 3, 4 zeros and a 1, 2. So 0.1234, 1, 2. And then after that, we'll continue to solve for this. It looks like we want the 5th root of this number, and then with the absolute value, that'll give us a positive and negative. So the 5th root, it looks like they took it already, but let's double check. We want this number raised to the 1/5, and I'll need parentheses 1 divided by 5. And they got 1037134. So this is the number that they got. We round to 3 decimal places. This is going to be on the negative side. It'll be negative this number, so negative 0.103 decimal places. So instead of a 3.7, we'll have a 4, and then 0.104. Okay, so what they're saying here is that if you remain within these values for your sine function, then you can use the 3rd degree Taylor polynomial, and your error will not get any bigger than this 0.00000001. Okay, I hope that helps.